Hi, my name is Shahroz Ahmed, and in this video I'm going to explain you the concept of differentiation in mathematics. First of all, we'll discuss some concepts and then I'll do some exam related questions. So let's start off with the concept of differentiation. Alright, so by definition, differentiation is basically it is the rate of change of any function, rate of change of any function, or we can put it other way. If we have to find out the gradient of the function, that will be called the derivative of that function. So we, in order to find out the, or we can just say the gradient of function, or the gradient of a function or graph. So this is what differentiation is by definition. Now rate of change is called the gradient, and let's make a graph and then I'll show you how we can find out the rate of change from a graph. So let's suppose this is a graph. It's a velocity time graph where velocity is in the y-axis, time is in the x-axis, and it's a straight line going up. So we have to find out the rate of change of this graph. So what we do is I'll take 2 points onto the graph and I'll do rise over run. So this is the rise, this is the run. So it's simple, rise over run. So in order to find out the gradient, I'll say that my gradient is equal to the rise over run. So that gradient is also called the derivative or the differentiation of this graph. But let's suppose we have a curve. We do not have a straight line. So let's suppose our graph is like going up like this, and we want to find out the derivative of this function at a particular time instant. So we want to find out the derivative of this velocity time graph at this time. Let's suppose this time is t. So what we do is we'll put a dot over here, and at this dot we'll draw a tangent like this. Now the gradient of this tangent will give us the rate of change at this point. So by principle, what we do is we will take one point over here on the graph, that will be xy, and I'll put another point on the graph over here, and the coordinates of this point will be x plus h and y plus h, where h is very small number so that it approaches to 0. So in this way we will say that the value of h is so small that it approaches to 0, because we want to find out the rate of change. So we will take h as a very small number, so there will be a very minute change in the x coordinate and the y coordinate. So when we apply the formula for the gradient, it will become like this. Gradient will become equal to the formula for the gradient is y2 minus y1 divided by x2 minus x1. Now in this graph we have x1 y1 as xy and x2 y2 as x plus h and y plus h. So the gradient will become like this: y plus h minus y divided by x plus h minus x. So since we can write y as a function of x, so I'll say that y is equal to f of x, and y plus h is equal to f of x plus h. So I'll replace these functions in place of y plus h and y. So my gradient will become equal to, I'll write it over here, my gradient will become equal to f of x plus h minus f of x whole divided by x plus h minus x, so x will get cancelled, so the gradient will become f of x plus h minus f of x divided by h. Now because h is very small value, so I'll put a limit, so that limit will say that h approaches to 0. So this is the method of finding out the derivative by a principle that we call the first principle. Alright, now there are also some other formulas in order to find out the derivatives, and we will use those formulas in the exam-related questions that we are going to do right now. So we can find out the derivative by two methods. One is the first principle, which is this formula, and the second method is by the use of the formula in order to find out the derivative. So now this is about the introduction. Now let's move on to the exam-related question. Alright, so here I have some exam-related questions. So here's the first one. It says y equals to x squared minus k under root x. So we have to find out the derivative. It says find dy by dx. Dy by dx is basically the symbol for the derivative. So now we have to use the formula that is called the power rule. So let me just write down the standard form of the power rule. So if we have to take the derivative of something like x to the power of n, so I write it as d by dx of x to the power of n. It means that we have to find out the derivative of this function with respect to x. So it will be like this: n times x to the power of n minus 1 d by dx of this function, that is x. So this is the general formula that is called the power rule. So I'm going to apply this formula over here and let's see how it goes. Alright, so this is the function y equals to x squared minus k under root x. So first of all, I'll just simplify this function. So y equals to x squared minus k under root x. So under root x, I'll write it as x to the power of 1 over 2. Now I'll take the derivative, so it'll be like dy by dx equals to d by dx of x squared minus d by dx of kx to the power of 1 over 2. Now the next step, now this is 2 over here in the exponent, so this 2 will come over here and we'll subtract 1 from the exponent, so it will become 2x minus, now this 1 over 2 will come over here and we have to multiply one, we have to subtract 1 from 1 over 2, so it will become minus 1 over 2 k x to the power of 1 over 2 minus 1. So it will be like 2x minus 1 over 2 k to the power of minus 1 over 2. So at the end we'll get the answer as 2x minus 1 over 2 k over under root x. So this will be our final answer. Alright, now it says given that y is decreasing at x equals to 4, find the set of possible values of k. So it says y is decreasing at x equals to 4 and we have to find out the possible values of k. So y is decreasing means the value of y will be negative. So we will get two values from here, so from those two values we have to choose the negative value. So let's put x equals to 4 into this expression and let's see what are the two values that I'll get. So it's y equals to 2 times 4 minus k over 2 under root 4. So I'll get y equals to 8 minus k over 2 times 2, or I'll write y equals to 8 minus k over 2 times minus 2, because under root 4 is plus minus 2. So one value is with positive, one value is with negative. So we have to work out the value of k so that the value of y will become negative. So we'll simply put this whole expression less than 0, because less than 0 is negative. So from there we'll work out the value of k. So it will be like 8 minus k over 4 less than 0. So I'll shift this negative k by 4 on the right side, so I'll have 8 is less than k by 4, Now I'll times both sides by 4, so I'll get k equals to, k is greater than 32. This 4 will get cancelled. So this is one range of k. Now in order to find out the other range, we will put this expression less than 0. So it will be like 8 minus k over minus 4 less than 0. So it will become 8 plus k over 4 less than 0, and my k over 4 will become less than minus 8. I'll times both sides by 4, and k is less than minus 32. So now I'll write down my interval. I'll write it here. So k is from negative infinity to negative 32, and it's like this, and 32 to positive infinity. So for these values, my y will be decreasing, and the values between negative 32 and 32 included, the function will be increasing. So this was a bit tricky, but this is how we can use the power rule and the concept of differentiation to work out our questions. Alright, let's do another exam related question for the differentiation. So we have a function that says y equals to 7 minus 2x to the power of 5, and we have to find out the derivative. So its derivative will simply be dy by dx equals to the derivative of 7. So 7 is a constant, so remember that the derivative for a constant is 0. So it will be like 0 minus, now for this one it will become 5 times 2x to the power of 5 minus 1. So it will become 0 minus 10x to the power of 4. So the final answer is minus 10x to the power of 4. So this will be the derivative for this function. I'll write it here. It will be negative 10x to the power of 4. Alright, now in the part B, it says find an equation for the tangent to the curve at point x equals to 1. So remember, as I've told you in the basic concept, that the derivative only gives us the information for the gradient, but in part B we have to find out the equation for the tangent. So in order to find out the equation for the tangent, we have to use the standard equation, that is y equals to mx plus c at x equals to 1. So if we put x equals to 1 into this expression, then we will get the gradient of this tangent, which means we will get the value of m. So let's work out the value of m. So I'll put x equals to 1 into this expression to work out the value of my gradient. So it will be like m equals to negative 10 x to the power of 4. So it will be like negative 10 times 1 to the power of 4, that will be equal to negative 10. So m will become equal to negative 10. So y equals to negative 10 x plus c. Now I have to work out my y-intercept. We do not have the y-intercept, so for that purpose I will use my original function. So in the original function I'll put this point x equals to 1, and I'll get my y-coordinate. I do have my x-coordinate, that is 1. Now against 1 I have to work out my y-coordinate. So I'll insert x equals to 1 into this equation. So y equals to 7 minus 2x to the power of 5. So it's like y equals to 7 minus 2 times 1 to the power of 5. So it will be like y equals to 7 minus 2, that is 5. So my value of y coordinate is 5, value of x coordinate is 1. So I'll put 5 over here and 1 over here, and I'll work out the value of c. So it'll be like 5 equals to minus 10 plus c. So c will become equal to 5 plus 10, that will be equal to 15. So 15 is my y-intercept, negative 10 is my gradient, and 15 is my y-intercept. Now I can write down the equation for my tangent at x equals to 1, and that would be y equals to minus 10x plus 15. So this will be my equation for the tangent of the curve at x equals to 1. Now it says determine whether y is increasing or decreasing at x equals to minus 2. So in order to do that, I will simply put x equals to minus 2 in my function, in my expression for the gradient. If I get the positive answer, it means my gradient is positive, so the function is increasing. If I get the negative answer, it means the gradient is negative, so the function is decreasing. So I'll simply put -2 into this expression. So let me just erase it. Alright, so gradient at x equals to -2 is -10 x to the power of 4. That will be equal to -10 times -2 to the power of 4. So it will be like -10 times, now 2 times 2 times 2 times 2, it will be 16, positive 16. So I'll get -160. That is a negative value. So because my value is negative, it means the gradient is negative, hence my function is decreasing. So it will be decreasing. So this is how I can use the concept of the differentiation to identify whether the function is increasing or decreasing. Now let's do another question. Alright, now here's the next one. It says it's more of like application based question. So it says a model helicopter takes off from a point O at time t equals to 0 and moves vertically so that its height y centimeter above O after time t seconds is given by this function, where the value of t is from 0 to 4. And in part I we have to work out the derivative of this function. So let's work it out, the derivative of this function. So it will be like dy by dx is equal to, this 4 will come over here, so it will be like 4 times 104 t to the power of 4 minus 1 minus sign as it is, then it will be like 2 times 26 times t to the power of 2 minus 1 plus 96 t to the power of 1 minus 1. Now I'll just solve it. So this 4 will get cancelled and I'll get t cube and minus 52 t to the power of 2 minus 1, that will be only t, plus 96 t to the power of 1 minus 1, that will be t to the power of 0. So t to the power of 0 is 1. So my dy by dx will become t cube minus 52t plus 96. Now in I it says to find out the double derivative. So this is the sign of double derivative, t square y over dt square. So we have to find out the double derivative of this function. So this is dy by dx and I have to take its derivative again. So d square y over dt square will become equal to 3t square minus 52 plus 0. So it will be only 3t square. So the double derivative of this function will be 3t square minus 52. Alright, now in part B it says verify that y has a stationary value when t equals to 0 and determine whether this stationary value is a maximum value or a minimum value. So stationary value means that the gradient at that particular instant is 0. The gradient of this function at t equals to 2 should be equal to 0. So the equation for the gradient of this function is right over here. Okay, so we will put t equals to 0 into this function and I should get the answer equals to 0, and then I'll identify whether that point is the maximum or the minimum. I'll show you over here. So let's suppose the graph is like this. If t equals to 0 is at this point, then it will be a maximum. If t is equal to 0 is at this point, then this will be a minimum. So let's find out first that whether it's stationary or not, and then we will decide whether it's a maximum value or a minimum value. So in order to do that, I have to put t equals to 0 into the function of the derivative. So t equals to 2. So it'll be like 2 cube minus 52 times 2 plus 96. So 2 cube is 8, 52 times 2 is 104 plus 96. So yeah, we got 0. So the function is stationary at t equals to 2. Now we have to determine whether the maximum whether it's a maximum value or the minimum value. So in order to find out whether it's a maximum or minimum, what we do is we'll put t equals to 2 into the function of her double derivative. So my double derivative was equal to, I'll write it here. So the double derivative t square y over dt square, it was equal to 3t square minus 52. So I'll put 2 over here, so it'll be like 3 times 2 square minus 52. Now if I get a positive value, then it's a minimum point. If I get a negative value, then it's a maximum point. So once I'll solve it, it'll be like 3 times 3 times 4 minus 52. That will be a negative value, that is less than 0. It means at t equals to 2, I will have a maximum value. Okay, so if we put t equals to 2 into the a function of double derivative and we get a negative answer, it means then that value is maximum. If we get a positive answer, then it means that that value is minimum. So this is it for part B. Now let's see part C. In part C, it says find the rate of change of y with respect to t when t equals to 1. So this is the expression for the rate of change. Rate of change means the derivative. So we will simply put t equals to 1 over here and we'll get the rate of change of y. So let me just erase it. So what I'll do is I'll put t equals to 1 over here and I'll get the value of the rate of change. So rate of change is equal to 1 cube minus 52 times 1 plus 96. So it will give us 1 minus 52 plus 96. That will be equal to negative 51 plus 96. So when I'll subtract it, I will get 45 as my answer. So 45 is the answer for part B. Part C. Now in part E, it says determine whether the height of the helicopter above O is increasing or decreasing at the instant when t equals to 3. So as I have told you, in order to find out the increase or decrease, we will just put t equals to 3 into my equation for the derivative, and if I get a positive answer, it means the height is increasing. If I get a negative answer, it means that the height is decreasing. So I'll simply have to put t equals to 3 into this equation. Alright, so when I'll put t equals to 3 over here, I will get dy by dt equals to 3 cube minus 52 times 3 plus 96. So as I've told you, if I get a positive answer, it means that the height is increasing. If I get a negative answer, it means the height is decreasing. So for this one, I'll get 27 minus 52 times 3, that is negative 156 plus 96. So when I'll solve it, I'll get a negative answer that will be equal to minus 33. It means it's negative, it's less than 0. So the height at t equals to 3 is decreasing. So that is how, by the help of the derivatives, we can know the rate of change of any function. So this is it for this topic. I hope you understand it. Thank you so much.